Yes, ready for recording the document. Okay.
Good morning.
Very good morning, sir.
Yeah, good morning, sir. So I think we are on live, so we can get started.
Yes, sir. Yes, sir. Okay. Shall we start?
Yes, sir.
Yes. Very good morning, one and all. Dear students, I welcome you all for this uh, virtual workshop, 3-day workshop on electric vehicle technology and future scope for this electric vehicle field. Okay. So, on behalf of Vishwesvaraya Technological University, on behalf of Honorable Vice Chancellor and Honorable Registrar, I welcome the team of Vision Astra EV Academy and also all the students who have taken active part and registered for this 3-day workshop. So, I welcome you all for this 3-day workshop. Mainly, this 3-day workshop is focusing on the trends and rapidly transforming the transportation sector driven by advanced battery systems, environmental concerns, and evolving consumer expectations. So, in all these areas, so there will be a lot of transformation that are happening, and the overview of current EV technology and future opportunities is a right workshop that going to address the issues related to the environment and also the requirement of electric vehicles in the present era. Okay, so this electric vehicle technology concerned with the area like battery pack, electric motor, power electronics, charging system, thermal management, and what are the type of EVs they are available in the market, and what are the technologies emerging in these areas, and what are the future opportunities for innovations, research, and also the present technology existing. So, with all these areas to address and to give some information over the electric vehicle technologies and the future job opportunities. So we have with us Rahul, head of Driveline FTP Industrial Terrain, Italy. And also we have Edu Jatvendra, co-founder and chairman, Vision Astra EV Technology, and Mr. Nikhil Jain from Vision Astra Technology. I welcome you all, sir, on behalf of Vishwesvaraya Technological University. So, with this brief introduction, uh, I request Rahul to go ahead with the sessions. Thank you.
Thank you so much, Basaraj sir, for your introduction and the welcome. So we'll have a quick, brief introduction about ourselves, and then we can get it started. Uh, Good morning, one and all. Over here, this is Nikhil Jain, CS, co-founder, CEO, Vision Astra EV Academy. So, Ayush, can you help us to share the flip the slides, please? Yeah. So basically, our vision and mission. So we are here, today, to empower our India's talent, basically to shape the entire EV industry. the entire EV industry is moving towards the automotive industry is moving towards the electrification. So that's our vision to create the talent talent pool, and our mission like is basically we want to be the number one leader in the electric vehicle design and the manufacturing in I think a decade time from now. So with this vision and mission, I would like to welcome my co-founder and chairman, Yadu Jatavedan, also onto the screen.
Hello, everybody. Wishing a warm good morning to all students of Visvesvaraya Technological University, and good morning to Dr. Basvarajappa. Thank you for inviting Vishnastra EV Academy for this session on 3-day online workshop on EV technologies. So, brief agenda about this 3-day workshop. Today, we have a special guest for all of you, Mr. Rahul Sagar. He is the head of Driveline FPT, Turin, Italy, and he's a very senior leader in the automotive industry for over 19 years. And he will share with us his insights on what is the transformation that is going on in the automotive industry right now. Along with that, we'll share something about what EV Academy, Vishnastra EV Academy, is doing in the space in India specifically, and focused here. We are based out of Bangalore in Karnataka, and what are the potential job opportunities and industry trends, who are the companies that are coming for hiring, etc. So that is today's agenda. We'll go for an hour with some Q&A sessions from you, which you can post on the YouTube live chat, and we will take it up here. On day 2 tomorrow, we will go a little bit in depth into some of the basics of EVs. Dr. Basvarajappa had already shared what we look for, which is some of the battery basics, the charging infrastructure. We'll focus on that, how the power is coming from the grid to the vehicle itself, what are the different conversions, different standards that is available on day 2. Day 3, we'll come back to a little bit of the future trends, what is happening, what are the benefits, as well as job opportunities, and followed by a Q&A. Day 2 and day 3 will be handled by Mrs. Raja Vidya, Assistant Professor, RV College of Engineering, who's also a program coordinator for Vishnastra EV Academy. So without much further ado, I will welcome Rahul on stage. Welcome, Rahul. Good morning.
Good morning. Good morning. Good morning, everybody.
Yeah, so just a brief things. Rahul and I have a deep, long history. We have been connected for over 20 years now, 21 coming up. And I've known Rahul, both of us graduated in the same year, 2004. And Rahul is from the automotive background, and I'm from the chip design background. And like I said, he's the head of Driveline at Fiat Powertrain Group in Iveco, which is a huge trucking group based out of Italy. I would now welcome Rahul to just have a brief introduction about his previous roles, where he did his studies, and how he came to this industry. So go ahead, Rahul. Can you just briefly introduce yourself and where you graduated from, and what is your tie-up with VTU, for example?
Yes, of course. Good morning, good afternoon, everybody. It's a pleasure for me to give you some insight about the industry. So I have deep ties with the VTU. I'm a VTU graduate. I graduated from VTU 2004. And then right after that, I moved to US. I did my master's from Michigan, University of Michigan, and I graduated that 2007. So I was very very passionate about cars. So naturally, that sort of took me to Detroit, and I spent about 12 years in Detroit. I spent my entire career in powertrain. Powertrain is basically the entire mechanical, electrical, electronics components that creates the power and then delivers into the wheel. So that includes engine, transmissions, all of the mechanical components inside. From Detroit, I moved to Germany, Stuttgart, Germany, again with the same company, Magna, and then from Stuttgart, I moved to Bologna, focusing more on electric powertrain. Now I live in Turin with a different company, which is a Iveco Group. I'm responsible for, again, in the same powertrain space. I'm specialized now in electric powertrain.
Wonderful. Thank you very much, Rahul. What is the, like you mentioned, you started your career at Detroit, right? So what is the importance of Detroit specifically, especially when it comes to automotive, for folks who are not aware of that?
Yeah, absolutely. So Detroit, personally, when I finished my university, or when I finished my engineering, Detroit was a place to be, because this is where the American auto industry started. It's where American auto industry lives. This is where the global auto industry looks to learn what is happening. Detroit has a lot of significance. The top three auto companies, Ford, GM, and Chrysler, are all located in Detroit. So this kind of a impact made me choose to go to Detroit. I always say I never went to US, I went to Detroit.
Wonderful, wonderful. And what about Stuttgart in Germany? What is the major significance of that area specifically?
Yeah, so also very similar, right? Stuttgart is where the the Germans would always argue that Stuttgart is where the birth of automotive industry happened. This is where Carl Benz, Gottlieb Daimler created the first cars, and it is the home of Daimler. It is a home of Audi. It is the home of Porsche. So it is also another very impactful city.
Wonderful. And now, what about Turin, that you are based out of? What is significant, especially in the Italian automotive sector?
Yeah, so that kind of explains my journey too. So Turin is the capital of Italian automotive industry. So where I'm talking to you right now, I'm 2 kilometers away from the biggest factory Fiat ever made, Lingotto. So this is the home of Fiat. And when you say home of Fiat, Fiat is Italian automotive world.
And all the other companies like Maserati and Ferrari and
Yes,
Lamborghini.
Maserati, Ferrari, they all. So this is where I used to live before, which is a city called Bologna. So Bologna is where Lamborghini, Ferrari, Maserati, etc., etc. So I kind of followed the path of automotive. Yeah, it's kind of a pilgrimage. You go from one place to another place and another place.
Yes, absolutely. So folks on the bridge, especially students, right? We always say Bangalore is the IT capital of India. Similarly, Silicon Valley in United States is the, of course, the hardware or the semiconductor capital of the whole world, including all the software capital. Now, similarly, if you look at automotive sectors, these cities are very, very prominent. Detroit in United States, Stuttgart in Germany, and then now Turin and Bologna in Italy. So with that, so Rahul, can you just explain to us? I'll go back to our slide deck to understand what is the importance of the new powertrain design, right? What is happening at this point of time, and So what is happening is the transformation happening in the electric, this powertrain. What does powertrain mean? And
So I was saying the birth of the automotive and how automotive field developed. So automotive field as an entire academic area or entire engineering field, it is 130 years old, right? And it started between Germany and US, and it has been developing ever since. But if you look at the key concepts of how the industry started and how the industry developed, the core of that never changed. It has always been an engine, a typical gasoline or diesel engine, and then you have some sort of a transmission, some sort of a mechanical transmission, a set of gears, and then you have wheels and the other things. So it has from where it started to where it is, it has improved a lot, of course. It used to be a very inefficient, very it has a lot of environmental.
Yeah.
It used to be a very dirty system in the beginning, but that has improved quite a lot. Efficiency has improved quite a lot, and that's where it has been until the new things came along, right? Which is quite recent.
So, what is the current efficiency? You said it is improved on the ICE. ICE means internal combustion engine, right? So it could be
Correct.
a diesel engine or a petrol engine, but that is the whole thing that you're talking about, and it's all a mechanical device that takes energy from one side to the other side, right? Can you please explain that concept and what is the new transition in the electric vehicle side that's happening?
Yeah. So how is the energy converted, right? In a typical ICE or internal combustion engine. So you have gasoline or diesel, or petrol or diesel. You will store it somewhere. You pump it from a petrol bunk and you store it somewhere. And this is getting burned in an engine. So engine literally burns it. And then because of the process of burning, because of the process of compression and expansion, you create force. You create this kind of a torque or force, and then the vehicle moves. Problem is it's a thermal process, right? You are actually burning, and you create a significant amount of heat. You create a significant amount of emissions, etc., etc. So to answer the question, what are we talking in terms of
Efficiency.
efficiency? We're talking about 40% efficient.
What does that
Right.
mean? 40% efficiency means what does that really?
What that means? That's a good question. What does it mean? So that means the energy that you put in, 40% of that gets converted into usable force or usable energy. 60% of that energy is lost. It's lost by heat, basically.
Yes. Yeah. So that means the efficiency of system, 100 units of energy which is stored inside the petrol, only 40 is really used. And that is after 100 years of engineering, right? Almost 100 years of engineering. So it would have been even worse in the beginning. Maybe, in the 1900s or 1910, 1920, etc. It would be 5%, 10%, 20%. And we have improved after 100 years to about 40%.
Correct. It's
Okay.
also not only just 40% at the moment. It is reaching a point where it cannot be improved anymore, right?
Cannot be improved. Okay.
Yeah.
It's a permanent loss.
Yes, it's a permanent loss.
Yeah, and you cannot recreate energy like that. So now coming back to the electric vehicle, what is the fundamental shift that is happening? And of course, we will ask the question why now as a second half. So what is happening and what is the current efficiency of that system on the right
Yes.
side?
So the right side, what's happening is you don't have a mechanism to burn fuel anymore,
Okay.
right? So energy is not coming in the form of a liquid that just gets burned. So
Yes.
this is the fundamental difference. No more engine. Instead of an engine, you have a battery, which is exactly same or
Similar.
in terms of the chemistry, in terms of the fundamentals, it's exactly the same as your phone battery or your laptop battery. So
Perfect.
if you think about that, we're also using components, or we're using products which requires energy.
Yes.
And when you think about a phone or a laptop, you do not think your energy source as something that burns fuel, right? You do not, drop petrol or gasoline into your phone and burn it, and you smell the emission and things like that. That's not normal. That's not how it works. So if you think in that perspective, why would a car require an engine? Why would a car require? It's just to power it, right? That's all
Yes.
it does.
Yes.
And that's what the new cars are. An electric car is basically, it is a massive battery, and that's what you sit on, the flat thing that you see on the side, and then you
Right.
have two electric motors and power electronics. Instead of instead of all the mechanical components, you have an electric motor which gets the power from the battery, and then it drives. That's
Yes.
it. It's extremely simple. So it's an order of magnitude different in terms of the number of components. So engine has all of these mechanical components, pistons, rods, injection, valves, blah, 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 blah. And now when it comes to an electric vehicle, you have a simple battery, you have a battery manager, you have more electrical and electronics things like your phone, and you have very less mechanical components.
Wonderful, wonderful. This is a very important segue for students to also hear this. And now moving on, right? So, what is the efficiency of the system and the
So
new
efficiency
system?
of efficiency of the new system is over 90%.
90%. So,
Yes,
about 90% of the energy stored in the battery can be used as useful energy. Only 10% loss. That's
correct.
tremendous improvement, right?
Yes.
With
It's
very limited emissions at the vehicle level. Okay, there's no emissions here, but fine, we'll figure it out like at a later point of time.
correct.
Now, coming back, so this transition, why did it happen now and not in the past?
Yeah, so it's a really good question. So why did it happen now? And the answer is battery, right? Because and it's also the reason why we all have a cell phone. The battery in our phone is lithium ion battery. So lithium.
Yes.
The reason why that's important is because it increased the energy density significantly, right? So energy density is the amount of energy that you can store in a given space, right? So higher the energy density, more energy can be stored.
Got
So
it.
the biggest advantage of diesel and petrol is it's insanely energy dense. Yes, you have to burn it, but it is very energy dense. So the problem with the battery has always been it is not quite energy dense. So you can only drive for like 10 kilometers. But with the lithium ion batteries, now you can really drive it for a really long distance. But it also had another problem. Batteries were always very expensive, right? So when people started looking, when lithium ion batteries came in 20 years ago, 30 years ago,
Yes.
obvious question is why it cannot be used on cars. Answer was yes, it can be used, but the problem is cost of the battery. So the cost of the battery has been very, very high, and it is due to this one company called Tesla who looked at this one and said that the reason why electric vehicles would not work is because of the battery. And then they started pushing on how do we make the battery cheaper. And today, battery is almost 10 times cheaper than how it used to be
20
about
years
12,
ago.
13 years ago.
Okay. Wonderful. So what made Tesla to come up with this? Was there any fundamental first principle thinking, and especially any learnings from the computer industry that helped to redefine the passenger car as what we see it right now?
Yeah, absolutely. So it's a good question. Why is it a first principle thinking? Yes, it is exactly that. Asking the question why something is the way it is, right? Is there anything fundamentally not allowing these things to cause certain things? Is there anything fundamentally inside the way something is put together not allowing something else to happen? So that's first principle. First principle is breaking a problem down into it is basic elements. It's first principles, and then saying why it doesn't work. So the reason there's a famous discussion between Elon Musk and one of his engineers. So he was asking why it doesn't work, and he says it doesn't work because the battery is very expensive. And he says why is it expensive?
Yes.
And he said yeah, it's because he's not getting a proper answer. Then he asked the question: if I buy all the materials from a stock market, all the materials of a battery, would it be cheaper? And the answer goes yes, it'll be 10 times cheaper. So then they focus on the battery manufacturer. So it is a first principle problem that they solved, and it has been many others have been solving as well. So the battery cost keeps on coming down from China at the moment.
Got it. So the summarizing this is there is a fundamental new shift. It's more efficient at the vehicle level. There is a new technology. It's a store of energy, because what happens in this automotive is you're just converting one form of energy to the other form, right? Automotive is all about transportation. Transportation, you need to move people and move goods. To do the movement, you finally need mechanical energy because your wheels have to rotate ultimately. So what energy do you store? What energy do you transform? Do you burn the petrol or diesel in chemical energy, convert into heat, and then convert it to mechanical? There is an efficiency problem there. Or you take the energy stored in a kind of a device like battery, then convert it to electrical energy, and then drive your vehicle. So ultimately, that is how this thing came about, and the transformation, right? So coming back to a fundamental like an EV architecture, can you just quickly explain what are the different systems that you will see commonly in a four-wheeler or a two-wheeler EV?
Yeah, absolutely. So we touched upon this one a little bit in the previous slide. So what you see on the floor of the car, which is generally a battery pack, right? So you can imagine like exactly like your phone, but many more of that. So
Yes.
much larger battery, but fundamentally the same thing as your phone. And then you have either on the back or a front, or in some cases, if it is an all-wheel drive, front and back, you would have this thing called an electric axle. So electric axle is basically three things together. You have an electric motor, you have an inverter which converts the DC current that's coming from the battery to an alternating current, and then you have a simple mechanical gearbox, and that's it.
Got it. I mean, there are further questions about why do we need an inverter and all these things, but we'll leave
Yes,
it with a further longer discussion. But
right.
we are just giving the basics in today's conversation, right? So I'll
Yes.
go forward. You have a very vast experience, and I think you are the right person to bring on this particular topic, being lived in US and Germany and now Italy. Please tell us about what is the automotive industry all about. How big is this industry? What are the major players? And how do you compare that against software industry, which is more prevalent and common in Indian universities, right? All of the software companies every student would know, but not much in the automotive side. So can you please help us educate on that?
Yeah, sure. So it's very simple, right? You guys are smart people. When you the size of an industry, to understand the size of the industry, you just need to see the complexity of the product and how penetrated the product is in the society, right? So you start looking everywhere. When you get out of your house, you need a car, you need a bus, you need a transportation device, right? And it is everywhere. This is number one, how much penetrated the product is. And you start looking at the product itself, how complex the product is. A vehicle is arguably the most complex single device in existence, right? It is extremely difficult to engineer. Hundreds of thousands of each automotive company has hundreds of thousands of people employed, directly and indirectly, and they make a massive number of cars. Top players would make millions and millions of cars. The total production of the automotive industry is about 80 million cars globally, right? US alone makes about 15 to 17 million cars in a given year. So it is a massive industry. And then the question is, how does it compare to the top software companies, right? Because we always hear about the Apple, the Facebook, and the Microsoft, right? If you compare the revenue of these companies, it's a good matrix to understand how big they are. They are very similar to the top automakers as well. So if you compare the revenue of Apple to the revenue of Volkswagen or the revenue of Toyota, they are,
Google.
yeah,
To
or
Google.
to the if you compare the top 5-10 companies, software companies to the automotive company, they're in the same range. So what is the bottom line? The bottom line is that it is a massive industry. It requires expert engineers year over year, produces these kind of things that are not possible to be disrupted that quickly.
And another major point is if you look at the traditional things like whether it's Volkswagen or Toyota or Stellantis Group, Ford, GM, these are the legacy, the top five, right? And then at the bottom, you see all this, Geely Group, right? China FAW, SAIC, BYD, and then of course Tesla. These are all coming from the bottom. Now all closing to, BYD is also $100 billion companies, which are all fully electric. Right? They're only fully electric, and then coming up massively to disrupt the traditional automotive industry with new models and new platforms, etc.
Exactly. Yeah. So on the top, you see companies that have been existing for 100 years. Almost all of these companies have been there for around that time. And now the Chinese companies are new, and Chinese companies are extremely focused on electric. So it is an incredible observation to see how quickly they're progressing on the electric vehicles. Almost 50% of the cars made in China are electric at the moment.
Yeah,
So
which is why it is very transformative, very important for Indian universities, Indian students, Indian engineers, as well as Indian companies to start, getting to this particular list. So I was actually talking to somebody very senior from Mahindra Group, the vice president, that Mr. Shankar, and just a couple of days in IEM Bangalore, and we just made an observation that in Formula One, right? If you look at Formula One racing cars, the top 10 companies, these are Mercedes is there, Red Bull with Honda, and then you have McLaren, then you have Aston Martin, then you have
Ferrari.
Ferrari, of course, Ferrari, all of them, right? And then if you look at Formula E, of course, there's no Indian company in this. And Mahindra was also saying, for past 100 years, India was not even there. We didn't even have an engine and other things we were importing. If you look at Formula E, which is also run by FIA, in the top 10, there are already two Indian companies. One Tata with Jaguar TCS, and second is Mahindra Racing. So in the electric version, there's a chance for Indian companies to come up with. Yeah.
Right.
So Rahul, just to answer this question. So there are these massive companies, they're huge. What is their current requirement? What are they hiring for? Why does it matter for us engineers?
Yeah, that's a good question. So, what are they hiring for? So, if you look at if you think about the slides I was talking before, the overall car is not changing. The suspension system is not changing. The electrical architecture is not changing. What is changing is the powertrain. Right? It is going from an engine, transmission, etc., into a battery, and then motor and power electronics. So that's what you call it as a powertrain. So powertrain is being shifted from ICE, internal combustion engine type powertrain, into an electric powertrain. So that's where the change is. Maybe just to touch one more point, right? India as a country has always been predominantly software engineering. Our biggest export is engineers, right? Mm-hmm. So with the shift in AI is also coming. It's not coming. It is there. It is there, and it is getting better and better. The software industry is going to have a massive disruption. Yeah. This is happening today. So what is happening with the industry like ours, this kind of a traditional industry like automotive industry? This is the core, right? Designing core products like electric motor, power electronics, vehicle engineering. These are never going to go away. There is no artificial intelligence model today, a physics informed neural network today that can replace a car engineer.
Yeah. So potentially in 5 years, 10 years, maybe. But right now, what you're saying is there's a need for electrical, electronics, and even computer mechanical engineers in the industry, because this is where the new hiring, everything will happen.
Correct.
Okay, very good. So moving on to the next slide, global EV landscape. We touched upon it. Maybe very quickly, what is the need of the hour for your industry, right? Why do you say that the talent is not available, and why is India an attractive place for companies to come in the future?
Yeah, absolutely. So what we are seeing is a massive adoption to electric vehicle. India is one of the lowest in terms of adaptation at the moment, but our expectation is that India is going to catch up, like India catches up on every other major technology shift. In India, you normally see like a very small adoption at first, and then a massive adoption a little bit later. So if you look at just that and think about India as the destination for you guys, yes, there's going to be a massive industry that's coming now. Second is global landscape is shifting to electric powertrain, which means all of these OEMs means companies that are making the cars, and then you have these tier ones which are supporting these manufacturers
like Bosch, Continental,
like Bosch, like Denso,
ZF.
like ZF, etc.
SEG. Yeah.
Right. SEG. They make the components for the OEM. All of them are now shifting to electrification. So the overall industry is very, very significant. So when you switch to a new technology, there are no experts available anymore. The industry experts doing these things for 30 years are all doing the other things. Now the new technology requires young people to be trained and then be ready for when these guys are ready.
That is a major thing, right?
That's the major thing.
Yeah. And what about Indian universities? Do they have the ready talent available for you to come and hire immediately?
No, so that's a classic Indian problem. So the classic Indian problem is we are quite disconnected from how the industry is going. But in this particular case, though, it is a new field, so the problem is even worse. Right. So when you don't have this significant connection between the universities and what is happening in the industry, the students will not be fully trained or fully aware of what is required from the industry. It does not mean to say that students do not know anything or students are not capable. It's just the fact that the industry is shifting so fast. So unless you're quite synced to what is happening, you will be left behind.
Got it. And India has a massive amount of talent, right? Raw talent. Today in India, almost like 3 to 4 lakh mechanical engineers graduate each year, right? About 5-6 lakhs electrical and electronic respectively graduate, and the computer science is more than that, 20-30 lakh, right? It's just 2 or 3 million out of a 1.5 billion that still graduates, but it's still a huge number. And just the sheer volume of engineers that graduate is huge. So finding employment for them, finding them thing is a good thing. So industry look for talented people, very highly skilled, right? So the problem that you're facing is you don't have skilled talent. You have talent or workforce, but not skilled one. Am I right?
Exactly. So it's not the quantity that matters in this case. It is the quality of the students that matters. So and it's a very difficult problem because you cannot do thousands and thousands of interview to find out one person if that person is good, right? You have a selection process becomes very very difficult.
So what really happens when you talk about skilling, right? One person is very skilled. What really happens in their curve, their growth and trajectory, etc., etc. Can you please share? Especially we have come up with two different curves, right? One for the skilled workforce, the unskilled. And the skilled, the pay raise for the skilled is much faster, right? Higher percentage growth per year than the lower side. So can you please maybe explain that when two students start off two numbers?
Yeah, of course. So skilled versus unskilled. So when I was saying if you have to find this as one talent and you look through the resume and you do not really find anything interesting, the problem number one is it'll be very difficult to get an interview itself. And then even when you get an interview and you get hired into a company will not give you a big salary because there is no guarantee that you are able to learn, you have the capacity to learn, etc., etc. So normally when you start off completely fresh in a company, you start off very low, and then it takes like 1 year, 1.5 years to really upskill you, and then from that point onwards, they can understand if you have the capacity to learn, if you are contributing to the company, etc., etc., and then start your raises after that. But when it comes to a skilled person, you use a different way to upskill you in this kind of a particular domain. Now this is a different story. You prove the fact that you are interested in an industry. That's number one. That's why you upskilled yourself. Number two is you're able to learn the things that this upskilling has done. So with these two, the hiring process becomes very easy, right? And they don't have to wait a year and a half to figure out if you are the right person. They can immediately know that you are the right person. And so generally the delta between the difference between the non-skilled versus upskilled is quite high. The assumption is it is almost twice in the current dynamics, right? So you normally, if you're unskilled, you get hired for like 3 lakhs, And then if you're skilled, you get hired for almost double, 6 lakhs on an average. Now, so that's problem number one. Number two is, as the years go by, what generally happens is, for the skilled person, he's already starting at a higher knowledge area, right? So
Yes.
you are involved in more problems. You're involved in solving more problems. People will
And
come.
the value you bring into the company also higher, so you get paid
Yeah,
more, faster rise,
you're
etc.
immediately providing value, right? You're not waiting for a very long time to learn things and then provide value. Immediately you're providing value.
Yeah.
So that gets recognized very quickly, and what happens generally is you have a salary raise which is much bigger than the fresher with no experience.
Yeah, got it. So this is great. So just to pick up on it, right? For example, within 5 years, yeah, you literally are more, or within 10 years, you get 3 times. When you started with 2 times, now you're at 3 times, and then it goes on. 15 years, it's 4 times, and then it escalates, right? So both me and Rahul, for example, are coming up almost close to our 18 years or 20 years in the industry, and we both are above the blue curve, right? Whatever we see here, right? Because we upgraded, upskilled, and then went places, and then came back with much more experience and being very valuable to what we provide, right? So with that, I think I'll have maybe thank you, Rahul, for your time and things, and thank you, Basarajappa. We will, sir, that we'll continue our conversation to EV Academy, how we can help the students at this point of time, and we'll let Rahul go. And it's very early in Italy right now, so have a great rest of the day, Rahul. Thank you very much for explaining what the industry is, and I encourage all the students to connect and reach out to Rahul on LinkedIn. He's available there.
Yes, thank you, everybody. Thank you, Dr. Basavarajappa.
And thank you, guys. So we will continue. I'll have a few slides on what EV Academy is, how the opportunities for the students at this point of time, and then move on to our day 2 slides, etc. Okay. So what is EV Academy? Nikhil, my co-founder, had explained to you. We are a institute. We train students, skill them on EV technologies, what we just Rahul explained. We have a center of excellence set up in RV College of Engineering in Bangalore. RV, as you know, it's one of the leading institutions across Karnataka. And on the screen, you have, our inauguration was done by Mr. Nagesh Basavanahalli, which is the non-executive vice chairman for Greaves Cotton Ampere. Ampere makes, two-wheeler scooters. So he's the executive vice chairman for Ampere, along with Dr. Shyam Sethi, who is the president of RV Trust and entire RV institutions, as well as Dr. Subramania, principal of RV College of Engineering. That is on the left screen here. And then on the right, you can see dignitaries and industry people from multiple companies. Raj Rajapan, who is the CTO and co-founder of Ensure Marine Solutions. They make battery packs, and they are designing powertrain for the marine applications, which is like boats and big trawlers, etc. Electric versions of it. Then Zora Khan, who is the CEO of IPEC. And then IPEC is the main charger supplier for companies like Ultraviolet, Aether, Hero Motors, etc. And Mr. Tobias Novak, who is a German guy. He's a director of SEG Automotive. SEG is a German company based out of course, Germany. They have a branch and a plant in Hosur, which is near to Bangalore, right? So they were there, and we had about 19 students who enrolled in our program. Where we help set the curriculum, industry-relevant curriculum, which I'm going to share with you guys, and organize different things, industrial visits, internship, and also we help 100% place these candidates who are coming to us with all the automotive companies that are there. And we bring kind of industry experts and mentors, just like you saw Rahul, similarly other places. And we have our own infrastructure and lab support, etc. Set up inside RV College, which is the center you're seeing. So Mr. Rahul had also visited us in person. And you can see the CEO, Mr. Nikhil Jain of Vishnastra EV Academy, along with Dr. Subramania, College of Engineering. And these were the students across Karnataka and Kerala from our first batch, who has already graduated, and many of them are already placed right now. So this is the fundamentals. This is the key thing, right? What do you really get to upskill in the things? In the next couple of days, day 2, day 3, we will get touch upon some of the basics for you as an online. But as you know, right, this is a very hardcore engineering problem. You don't get to learn online things. You have to be in person and physically touch and feel and and look at things, including some programming and other things, etc. But fundamentally, this module, you have split it into 8 or 9 modules, and you can see it like a start and then end, like a race car, like a car. But we touch upon what is the EV powertrain design, system design, architecture, high level overview. We go into depth of battery design, different battery cells and chemistries, and also we have hardware class where we actually train students to assemble their own battery pack, do their own simulations. We do MATLAB and modeling of thermal designs of battery packs, which is very important. We'll explain why it is important maybe very briefly, but in the higher end thing. And then there's something called battery management system. It's a software along with a small hardware and microcontroller, which is very important, which actually measures different batteries and how they are performing, etc. Without this, no vehicle can operate. Then there are power electronics and for the charging and discharging, as well as for the inverter design, which is very important because you are converting one form of voltage to another form, right? DC to AC, etc. Then you have embedded systems required for motor and controller, MCU. We have motor controller unit, and then of course the entire e-axle and motor design, etc. So folks are primarily from electrical, which is EEE, ECE, mechanical, or any allied branches. They have a 4-month in-person program, and with 1-2 months dedicated entirely for placement drives, right? So this is again what we have. We have 4-month program, about 400 hours of program with expert mentoring from US, Italy, Germany, etc. And hands-on training, about 70% is hands-on. And this entire program is certified by Automotive Skill Development Council, ASDC, which comes under National Skilling Council, NSDC. And this is only eligible for final year graduates who are already graduated, like especially like for you, if you're already graduating in 2025, this is the right point of time to come join and then get trained. Some of the global mentor network, you just met Mr. Rahul. He's from Italy. Similarly, we have folks from American Axle, Mr. Martin from Germany, Mr. Kishore from NRB Bearings in Detroit, US. Mr. Raj, he was in Marelli. Now he's heading another company called Virality in Boston. He's also in the automotive industry. Mr. Matty Vidit, he was ex-Marelli from Michigan, US. Mr. Sujish is vice president for Morgan Stanley, helping with the energy side of things. And Mr. Subit Vasu is a professor, PhD from Stanford University, now a senior professor at University of Central Florida. These are some of the mentors that we bring in. So I'll quickly, take a second to show you a quick video. I'll quickly add this to stage. Okay, this is a video of a director or a co-founder of a company called McQueen. Okay, McQueen hires students from us, from EV Academy, and you can hear the owner of McQueen, Mr. Dr. Shiva. Dr. Shiva is well known in this industry, and he's just talking to the students of EV Academy about why they hire only from EV Academy and not anywhere else. Okay.
Why we don't hire from regular college and why we want to hire from EV Academies? So we no need to teach you from the, at least you know what is, now so many questions you ask, what is hub motor, mid motor. If I hire from engineering college, I have to teach first motor, then how it works, then mid motor, then hub motor. It takes 6 months to 1 year to bring into one motor first. But from EV Academy, you are ready. So what I have to teach you is which is best efficient, not really hub motor or mid motor. This you already know, where it is mounted, how it works, and these things you already know. So I may save almost 1 year if we get some students from here. So 1 year.
So it's very clear, right? That is what Dr. Shiva believes, and a lot of other companies who actually come to hire from us also believe. They actually save time because they don't have to undergo a fresh student graduate with no knowledge on EV technologies and train them for 6 months to 1 year. That's what Rahul is also telling. Right? Normally, every company, legacy because of IT and other things, they used to just hire and then train them internally and do it. But automotive companies don't have the time or the energy to do that. It's very difficult also because these are all hard, engineering concepts. So it's good that you get people who are already trained in this subject. Then directly they will be able to hire, and we have the evidence also. So right now, I will be lucky and saying in just 6 months, we have multiple companies. We have connections with about 30 to 40 companies. That is the unique value that Vishnastra EV Academy brings to the table. Today, companies like, I will show you the real people also, Chara, Ultraviolet, TVS, McQueen, Matter, MBTEL, Simple Energy, SCG, IPEC, of course, Ather and Tata Motors that was in the hiring. All of them have come for hiring, and we just had 18 students. Okay, and some of the students are getting multiple offers from different companies. So this is the unique thing, and this is, I'm only sharing about 13 15 companies here. We have about 30 to 40 different companies across North India, Delhi to Gujarat. Matter is based out of Gujarat, and then Bangalore, and then Chennai, Pune, and multiple companies are coming and hiring, qualified and talented, not just engineers, not just for their R&D, but also for their internal procurement and manufacturing and different lines. Right, they have a lot of requirements, and it will be a good option for students to understand this. So this is it, right? This is a TVS Motor campus hiring team with Mr. Vignesh and his colleagues. They had come to do their thing. This is the ultraviolet team. I'll show you what the ultraviolet bike and everything is. This is their head of Mr. Bharat. He's from Mysore. And Dr. Suyash, he has a PhD in power electronics from North Carolina State University. He hired this student, Miss Aishwarya, from us, and the mechanical students are undergoing the current hiring in ultraviolet right now. Today evening is the interview process. This is Dr. Shiva from McQueen. And they also hired from this. They are a major motor manufacturing company. And of course, everybody heard about Ather. Ather is one of the leading top 5 two-wheeler manufacturers in India. One of the originals. They started their company in 2014, and now Ather is kind of hiring students from us. And of course, Maruti, the well-established Mr. Puneet Chadda, Senior Vice President of Maruti, has visited us in person along with his team. All the way from Delhi, they had come to visit us and look at our academy. And it's not over. It's a small sample size only. This is the IPEC team. IPEC is currently hiring from us. We have taken them to industrial visit. They actually make the chargers, power electronics. Students are going to their R&D team. And this was the entire team from multiple companies, actually. This is myself here. This is Nikhil. And of course, Rahul just met. Om Kumar, he's the head of advanced engineering for Switch Mobility. Switch Mobility is a part of Ashok Leyland Group. And he's the heading the entire engineering team there. And of course, this is our batch. Mr. Rahul Sagar, as I said, head of FPT Industrial. Mr. Shreyas Sitapati, he's the chief engineering head of engineering for Ather. He's here on the screen. And also Pramod Nanjin-Swami, he's a vice president of Scient. He's also a part of that group, right? So we had multiple programs in RV and doing that. Now, gladly, we want to say just thanks to Mr. Basav Kumar, as well as the VTU Vice Chancellor. We are also partnered with VTU. We have signed an MOU such that we can help students from all VTU colleges, as well as all other engineering colleges across the nation to do this EV training and skilling and full placement. This is SCG Automotive. SCG, as I told you, is a German company. They actually make the motor and controller. And in our campus also, we have SCG Automotive motors for students to learn. And this is the during the placement time. This was just very recently, just a month ago. Jacob and Anusha. Jacob is from College of Engineering Trivandrum, and Anusha is from KLE IT Hubli. They both got placed at 8.5 LPA CTC through us. And this is Mr. Mahalingam. He's the CTO and co-founder of Chara Technologies. I'll explain what Chara does. This is one of the companies that come for hiring, and this is their entire team, Mr. Rajit and other people from their organization, and of course, rest of some of them are our EV Academy students only. And so this is Jacob, and this is Anusha. Anusha is in this yellow dress. Okay, and then of course our next company was Ultraviolet. So they have hired from electrical department Aishwarya. She has a master's from College of Engineering Trivandrum. Hired for 6 lakh LPA at Ultraviolet, and Ultraviolet is currently hiring and interviewing the mechanical engineering students. So that is happening at this point of time. And this is such of the other students that are already placed. Purna from Government Engineering College, Ramnagara, Najia again from College of Engineering Trivandrum, Sai Siddhartha from Hyderabad, Siddhartha College, Hyderabad, Muhammad Adnan from Sri Siddhartha IT, Tumkur, Ashwin Tambi from Government Engineering College, Thrissur, and Satish Kumar from Dr. Ambedkar Institute in Bangalore. So multiple students from mechanical, from electrical, electronics, everything. They are getting hired at different companies. Okay. So recently, one more company came yesterday. They announced one company called Matter. So I'll just talk about these companies that are hiring. One is Ultraviolet. This is a very modern, absolutely new design. we work with a lot of companies. There are two-wheeler companies, there are bike manufacturers, there are scooter manufacturers, there are actually controllers and motor companies, some battery companies, etc. And of course, four-wheelers, passenger cars, buses, everything. So it's a huge, wide spectrum. I'm just sharing 3 or 4 different companies that will come. Ultraviolet makes their fast cars, fast bikes. One of the models is called F77, and you can see the spec and the range, etc. So as an engineer, it's a great opportunity for us to have an Indian company. It's a great honor for things, and they Ultraviolet recently broke the record, which was held by TVS Motors for the fastest Indian two-wheeler. Their speed is about 250 kilometers per hour or something. So they broke the record, which is held for 30 years by TVS Motors with this new bike. And Ultraviolet, of course, TVS is an investor in Ultraviolet, so they are also backed by TVS Group. And this is a great company. And then similarly, Matter is based out of Ahmedabad, Gujarat. Yesterday they announced they are hiring one student from us, a mechanical student, with a very good package, 5 to 6 lakh. And then they also make a two-wheeler. It's a bike, a form factor with different specification, very fast thing. So there's an example of another company. And then this is Chara Technologies, again based out of Bangalore. Where they make sustainable motors. What they call is it's a rare earth free magnetless kind of motor. And why it is important is because for geopolitical reasons, right? You are all smart, because this motor and all does a lot of magnets and rare earth materials which only come from a certain country to our neighboring country, right? Which is a very big country and a very wealthy country now. And because of strategic reasons, we want to have less dependency. So this company is making unique motors, which is more environmentally friendly, as well as they use non-rare earth material kind of thing, and they have their own controller. So they also hired from us Power Electronics and two people I told you, Jacob and Anusha. And moving on. So this is just high level about the program. We are coming almost to the 1 hour mark where we open up for questions at this point. So this is a fully in-person. We do conduct our training for all VTU students in Bangalore. Our next batch is starting in June immediately. So folks who are immediately graduating and coming on, and if you really love and are passionate about automotive industry, passionate about working on EV designs, working with the EV industry, in kind of jobs, then this is the right place for you. Certified by ASDC as well as RV College of Engineering, and we do full, Monday to Friday, 9 to almost 5 o'clock. We are in different practical and theoretical sessions. And it's a 4-month program. So if you start in June, mid-June, July, August, September, by September, October, we will have your placement drives ongoing. Okay. So this is a high-level thing. How do you do? You can scan your QR code. I'll share the link with this, and it will be part of this YouTube journey also. And there's an admission fee, of course. It's about 10 to, including GST, 10,000 plus 18% GST. That is it. And then there is a module and other things, etc. So that is a high-level thing. And you can always reach out and connect to us on our social media platforms. So you guys are free to kind of connect and ask us questions. And we'll now open up to some questions on the bridge, right? So I'll ask my IT team to please share some of the questions which we can answer right away. Yeah, so Santosh asked the question. I'll just quickly answer this. Santosh, right? Yeah. So Santosh's question was, what is the duration? So Santosh, duration is this is 4 months. Okay, 4 months program, and yeah, it is written here, and with 2 months of placement, right? So the entire program will be around 4 months. So with multiple modules which I shared with you, right? Each module will be about roughly a week to 2 weeks, where we start with the EV architecture, system design, concepts, energy flow equations, understanding how much battery pack is needed for which motor, which controller. Then we go into the deep under the battery depth, into understanding BMS solutions, wiring integrations. In fact, I'll show you a cool video. Okay, let me show you a cool video. Let me see how I can add. Am I presenting desktop? So this is one of the vehicle integration modules. So this is students. If you guys are seeing this, they are actually integrating a naked chassis. It's like an Ola scooter with completely stripped down, and they are now integrating all the different components, wiring harness, motor and controller and battery integration, everything, to finally get it to a working condition. It's like a 2-3 hour session that they did, and finally the outcome you can see quick, like a fast mode. They finally get it to a working condition, and then they're driving it around. This is visible to all. Yeah. So that is just a fun some things that we do. Coming back. Yeah, so yes, good question by Praveen. Question is for freshers. Yes, we take people with 0 to 2 years experience. So even if you're just a fresh graduate out of 2025, we can train you. If you are from electrical, electronics, or mechanical streams, then yes, we will train you and then place you. Yeah, it can be done. And companies do come, because once we have the deep connections with the industry, the trust, I showed you all the companies that have come already. They are very happy to hire from us. Even if you are a fresher, we actually help you get 100% placed, right? There's no shorter version for 2 months. The reason is we have to go through the depth, because when you face interviews, so what really happens is, let me go to the next couple of slides, right? So our day 2 and day 3, when we come back on day 3, I encourage you to come back on day 3, because we'll go over some of the questions that companies are asking. What kind of fundamentals that you need to learn, right? From which course, right? From electrical machines and motor controller, what are the things to learn and do? From mechanical students, what are the things to follow? What are the common questions they are getting? What are the projects that companies are expecting, etc.? That will be on day 3. So day 2, tomorrow, we'll have Professor Vidya explain to you some of the deeper concept of the batteries and basics, charging network, why it is important, how is the energy flow, etc. And then finally on day 3, I'll also come back and we'll explain some of the questions that you can get, right, when you go to interviews. Otherwise, what happens is these days it's very very tough for young students to appear in front of companies. Like Rahul was saying, right? There's a huge volume, lakhs and lakhs of people are graduating. We also get a lot of applications, but it's very hard to screen and select the right people. So that is why I encourage and I highly acknowledge Dr. Basavarajapa's initiative. Right, it's absolutely phenomenal that in a second, the moment we sign up with VTU, Dr. Basavaraja actually came on board saying, "Sir, we need the session. We want to really understand. We want to talk to people from the industry, learn from them." And I couldn't get a better person than Rahul, with almost close to 20 years of experience working across US, Germany, and Italy, and having a huge experience. Rahul works with all the CTOs and CFOs of people like McLaren and Aston Martin and the Japanese companies, etc. He's constantly traveling. So for me also to bring him on to our academy one day to just meet all the current students was a phenomenal opportunity, right? So and it's not just words, like multiple companies from multiple people have come and acknowledges, right? So here Rahul himself personally came, visited us, spent almost a day with the students, interacting with them, talking to them, looking at their projects, what they're doing, and giving them guidance and advice, which you rarely get people of this level to come in, right? Same way, I'll talk about ultraviolet, for example. Dr. Suyash, PhD from North Carolina State University, on the top, right, is extremely busy. So we got him, and he was very happy. Similarly, there's another team, Simple Energy team. I haven't put the slide. They also came. The CTO, Mr. Kiran Pujari. Simple Energy is based out of Yelahanka. Myself and Nikhil have personally visited all their offices. So there are so many other companies. I didn't include Sun Mobility. Sun Mobility, for example, is started by the Maini Group, based out of Bangalore. It's very well known. Sir Basavaraja, sir, you already know, right? Maini Group, they brought the first electric vehicle car in India, the Reva, which they sold it to Mahindra earlier. So we had been to their Sun Mobility office just last week, and they are very interested to hire future students from our next batch onward. So it's phenomenal. Then similarly, Numerous Motors. Numerous Motors is based here near Jayanagar only, Jayanagar, JP Nagar area. And the founder of Numerous Motors is son of Mr. Shibulal. Shibulal was one of the co-founders of Infosys. We can look it up. So a lot of companies are there. And then another company which we didn't talk about is River. River is again based out of here. Then there is, of course, Ola right there. Aether we mentioned, Ampere. And then if you go to Chennai, another 10 to 15 companies. Pune also, I don't have to expand. There will be more
Of course, lot of players are there. Many players are into the electric vehicle technologies nowadays. Even the existing automotive sector also developing EVs. Am I correct, Ron? Hello. Am I audible? Hello. 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 Am I audible?
Hello, am I audible?
Yes, yes. Yes, yes.
Okay, got it. Yeah, so I was just explaining and also adding. So this is the phone number you can reach us. Okay, connect with us directly, and we will. Yeah, there are some technical issues, and we can help you. So overall, details, many things. If you have questions, let us know, and you can connect to us on our social media platform and do that. Right? How do you enroll? It's a very simple process. Just need to hit the application button on our website. I'm requesting our IT team to share our website in the YouTube link. So then, and the course material details, so that they can take it forward, and students can ask any questions.
Hello. Am I audible?
Yes, sir.
Of course, looking into the job potentials and the technology developments, this is a right area where the students can fetch huge job placements. So in this directions, we thought of creating some awareness regarding the future scope for the electric vehicle technologies. So in this context, the Vishwesvaraya Technological University also initiated the initiatives where we can offer the internship for the final year students in the area of electric vehicle domain. So this is the main concern, so that we need to transform the same message to the students, so that internship opportunity for final year in the area of electrical vehicle technology. So definitely that makes some encouragement and interest in taking in further higher studies in the area of electric vehicle technology. So as Deputy Director of Vishwesvaraya Technological University Postgraduate and Skill Development Center, Talakal, we have initiated an MTech program in electric vehicle technology from last year, and the currently we have connected with many COEs, so where they are making the students expertise in the different domains, where maybe the improvement in the motor sections or battery areas, or the body part of the automotive concern to electric vehicles. So this is how the different domains are going to be addressed, and the postgraduate program, it is in, instituted in our institutions, and the students who are willing to join MTech program also can opt the admissions through the PGCET, and a very nominal price, and it's an excellent infrastructure we have at VTU postgraduate and skill development sector Thalakal. It is in Koppal district of Karnataka. Okay, So this is a campus established in 23 acres where we are imparting the postgraduate programs like MBA, MCA, and MTech in EV technologies. And also, it's an exclusive skill training center where the different skill training activities will be conducted to the students. Different certificate courses are also designed, and the students of VTU can make this opportunity and can encash this opportunity to mm, upskill their skills. Okay, this is what I want to convey, and we'll continue the session tomorrow at the same time. Thank you for your patient listening. Okay.
Thank you, Veres. I have a couple of questions. I'll just quickly answer. So it's a 4-month program. Anybody who has doubts, questions, please reach out to us, connect to us both on Instagram as well as the phone number we shared on the YouTube. Second thing is, people ask about battery technologies. What are the challenges in EV? Yes, these are correct thing. The challenge here is the cost of batteries, the new materials. India does not have any original research done on battery technologies. There are very few companies. There was a company based out of Bangalore which had very high promise called Log9. Log9 made a graphene-based batteries, and I do not know what is the current status of what they are currently doing. So there is one company based out of Bangalore. Similarly, there are few. There are battery recycling companies, Urja and few others based out of Delhi, North India, etc. that are coming up. But most of the batteries are imported from China, which is again not a great, national security issue for a country, huge country like India. We want to develop our own batteries and resources, right? So that is one of the challenges going back to petrol, diesel. We don't produce any of those things. We have to pay extra money to foreign countries to get all these things. Again, it's a national security risk. So we want our engineers and programs to work on battery design and come up with new technologies. So that is for the future. The other challenge is, of course, the motor design, etc. is a very complex field. Primarily, currently, Europeans are masters at it, even the Americans, and of course, China's right now. So India, there are a few motor companies like Chara. It's also a startup. There's only 50 people there. It's a great company. They're founded by ex-Intel folks, Mr. Mahalingam and Mr. Bhatta. These are all 50 plus. They're really good, right? Similarly, McQueen, another motor company based out of Bangalore. But again, further advancements of heavy duty, high motors capacity for driving our trucks, driving our fast cars, etc., needs to be developed. So that is a future area of research. And then all the inverter and power electronic controls. Then IDAS, which is autonomous vehicle development, right, for our Indian roads, Indian conditions. That is a future area of research and growth for us. So and multiple companies, both European as well as Indian companies, work on this ADAS and other things. And a lot of companies right now, for example, Ultraviolet is coming up, and Aether also have announced in the next generation of vehicles they will have some radars to sense vehicles, passenger directed. But that's only a two-wheeler side. But for four-wheeler, it is even more important, multiple cameras. So the recently launched Mahindra, if you have known, right, the Mahindra BEV, XC7, etc. This is called modern born electric vehicles from Mahindra. They are fully loaded with a lot of advanced ADAS systems. They are level 2 capacity, but it's a long way to match the Tesla, which is almost at level 4 with fully autonomous systems, right? Level 5 is ultimate autonomy. You don't even need a steering, everything. It will drive on its own. So nobody has reached level 5 yet. So the most advanced is Tesla with level 4. Okay. Does this answer your questions, guys? And one of the major important takeaway is here is EV is only a 10-15-year-old technology, right? While the ICE and petrol and diesel engines have been there for 100 years. So in the 15 years, you shouldn't make a judgment on EV based on the first 15, because the next 5 years, 10 years could be even more transformative. And it might have a next leg before the next technology comes in, right? So things like solid state batteries, it's a great thing. Until we put more research in and coming well. So instead of lithium ion, maybe there's some other chemistry which we don't know about, right? So original research, including universities, the top universities in India have to put a lot of money and effort and research into developing these technologies, and then industry will take it forward and do that, right? So I think there is a huge area of importance. So I actually lived almost half my life in US before moving back. So there are a lot of expats who will come back, people like myself and Rahul and others who will come to India and then help the future generation with both projects, both work and research that can take India to the next leap. Right? That is our hope. That's what Dr. Basavarajappa is also mentioning. That VTU is also putting a lot of effort to do advanced research on this field. Okay. So we'll stop here for questions. Sujay, unfortunately, I will not take this question about impact on existing power grid and other things. Yeah, power grid also is very important, because as more and more need of charging is there, we are not going to get away, right? Nobody will stop using electricity permanently, right? Once humans invent something which is better, faster, we are not going go away. I'll give an example. The moment we invented fire, right, it is useful. We are not going to go back to the age where we did not heat our food. Okay. Once we discovered fire, once we found out that fire can be used, we started heating our food, not eating raw food. Second example, once we discovered wheel, right, we said, okay, wheel is better way to push the bullock carts and other things and go forward. We are not going back. Similarly, once we found electricity, right, everything that is powered, light bulbs, tubes, everything, electricity. Similarly, iron box. Earlier, what you used to do, iron box means you put coal and put it and then do that, right? No longer that. You just plug the iron box to the circuit and do that. Similarly, once we figured out, let's say mobile phone, right? Rahul explained. Think about a mobile phone. If you're inventing a mobile phone 50 years ago, imagine putting a small engine, burning petrol into this, like we had the ink pen and other things, and then having the fuel and having a mobile phone. Sounds ridiculous, right? Similarly, when we go to the electrified world where everything is electrified, and then next phase will be you put AI into that electrified things. Maybe you put AI into a washing machine, you put AI into a iron box, you put everything, right? That is the first phase. First is a mechanical device without AI, which is a machine which does mechanical job like an iron box without any electricity. Second, you electrify the device. Third way is you add intelligence to the device, right? So all this means we as a human society, we need more and more power. We need absolutely more power. So smart engineers have to come up with new technology. Maybe it is solar is the answer. Maybe it is wind. And we have to have a huge deployment of that across the nation. Then only we will be energy independent, energy self-sustained, right? We cannot look at the current grid and say, yeah, what about the current grid? Will EV if everybody converts to EV, will the current grid support? Absolutely no. Current grid will not support. So what do we have to do? We have to 10x the current grid. It's like asking, can we drive on a 2-lane highway? No, 2-lane highway is not possible. Now we need a massive 6-lane highway, right? Or an 8-lane highway, and we need to find space to build it. So it'll happen. Does it answer your questions? I hope it does. Thank you, guys. Thank you very much. And we will see you tomorrow around 10 a.m. For the next session, which will be the fundamentals of EV as well as the architecture and then battery technologies. Thank you all. Thank you, sir. Thank you, Basavarajappa, sir. And
okay, thank you.